The chain rule. This is another rule for finding derivatives. The chain rule is if f of x I'm going to start over. If h of x equals f of g of x. So h of x is a function of another function. Then I'm going to rewrite what I just wrote. Nobody could argue with this. If this is true, then this is true. What we're going to say is we can do anything we want to one side of the equal sign as long as we do the same thing to the other side. We can put this symbol on the left side of the equal sign, the prime, as long as we put the same thing on the other side, like that. But we must always remember to multiply by the derivative of what's in the parentheses, which I'm not doing on the left side only because the only thing in the parentheses is x. And we are multiplying by the derivative of what's inside here because the derivative of x is 1. So this is called the chain rule. A specific example is right here. This says that this rule, we're going to refer to this as the power rule. It's a specific example of the chain rule. The derivative with respect to x of a, any number, times u will be some function of x, raised to a number. This exponent has to be a number. There's 4 things to get the answer, 4 things we do. First thing is the number here, the exponent, and the number in front get multiplied. The second thing is this thing in the parentheses gets copied. The third is this exponent n gets reduced by 1. And the last thing is we multiply by the derivative of u with respect to x. This last thing here means multiply by the derivative of whatever is inside these parentheses. So 4 things, 1, 2, 3, 4. An example, suppose y equals 3x minus 7 to the second power. Well, we can get the derivative of this because 3x minus 7 squared is 9x squared minus 21x minus 21x. That's minus 42x plus 49. Therefore, the derivative of y with respect to x, term by term, is 18x minus 42 plus 0. I'm going to do this example another way to illustrate this new rule here, the power rule. So, same example. Y equals a number times 3x minus 7 raised to a number. Everything up here is perfect. The blue is the correct answer. The other way to do this is dy dx. There's 4 things underlined in green here. 1, 2, 3, 4. An means the 2 and the 1 get multiplied. The u, meaning whatever's in the parentheses, gets copied. That's the second thing. The third thing is the exponent gets reduced by 1. The 2 becomes a 1. And the last thing is we say don't forget to multiply by the derivative of what is in the parentheses. in the parentheses is 3x minus 7. The derivative of 3x minus 7 is 3. So doing it this way, there's a 2 and there's a 3. 2 times 3 is 6. And the 6 is times 3x minus 7 to the first power. And that's the correct answer, which also could be written after distributing 18x minus 42. So there's the answer one way. There's the same answer. 3x minus 7 to the second power. We can find the derivative by first multiplying and then differentiate. Or we could use the new power rule. Multiply, copy, reduce by 1, multiply by the derivative of what's in the parentheses. Here are some more examples of the chain rule. A sheet you received earlier said that the derivative with respect to x of sine x is cosine x. These rules are for when this is something not just simply x. If we need the derivative of the sine of something other than x, we can't use this rule. So the derivative of sine u is cosine u, cosine the same thing that's there. But we also are going to multiply by the derivative of the thing that is pointed to with the red arrow. So these are all the same rules you had before, except these are all u's instead of x's. These are all u's over here instead of x's. And each one of these rules ends in times du dx. That piece at the end is called the chain rule. So we're going to now do a few exercises from page 146. Exercise 12. Y equals x to the third times 2x minus 5 to the fourth. The derivative of y with respect to x. This red and green is called a product. The derivative of a product is the first times the derivative of the second. When we write down the derivative of the second, we're going to ignore this red thing for a bit. The derivative of the second is 4 times 1. 2x minus 5 gets copied. 4 becomes a 3. And we multiply by the derivative of what's in the parentheses. All this green is the derivative of the second. We're halfway through the product rule. The derivative of a product is the first, which is red, times the derivative of the second, plus the second, times the derivative of the first. To simplify this, we're going to take the simple stuff, the 4, the 2, and the x cubed, and write that at the beginning. 4 times 2 times x cubed, 8x cubed. The 2x minus 5, temporarily call that something simple, like j or r. Just pick some letter. So right here, temporarily, we're going to write that this 2x minus 5, we're going to call that r to the third. And then after the plus sign, we're going to write the 3x squared first, and next to it we're going to write, I said r, but I meant j, sorry. I said you could use any letter you want, but I picked that letter. So after the plus sign is 3x squared times j to the fourth. Right here, this green is j to the fourth. By doing this, it's easy to factor, because we see in both of these terms, x squared is in both, j to the third is in both. So we're factoring that out of 8x plus 3j. Because x squared j to the third times 8x is this first term, and x squared j to the third times 3j is the second term. The greatest common factor is factored out. So that's x squared times 2x minus 5 to the third, parentheses 8x plus 3 times 2x minus 5. Just turned each j back into 2x minus 5. X squared times 2x minus 5 to the third times 8x plus 6x minus 15. So here is our simplest answer. X squared times 2x minus 5 to the third times 14x minus 15. This is the derivative of y with respect to x for exercise 12. It is not quick. Number 18. Y equals 1 plus the cosine of 2x, and that's raised to the second. Now, in the exercise in the textbook, the 2x does not have parentheses around it, but I'm going to put them in. And there's no number in front of the parentheses, so I'm going to put a 1 there. The derivative of y with respect to x. That number here, the exponent, and the number there get multiplied 2 times 1. Whatever's in here gets copied. 1 plus cosine 2x. The exponent 2 becomes a 1. And now we multiply by the derivative of what's inside here. The derivative of 1 is 0. The derivative of cosine 2x is negative sine 2x times the derivative of what's in those parentheses. The derivative of 2x is 2. So here's the new thing. This is new. The derivative of cosine 2x is negative sine 2x times 2. This is what we call the chain rule. We say don't forget to multiply by the derivative of what's in the parentheses. So just rearranging the order of this. This 2 way over here and this 2 way down there can get multiplied. And that negative can go to the beginning. And say negative 4 times 1 plus cosine 2x times the sine of 2x. So the negative, I'll remind you, that negative is way here in the beginning now. Everything else is there. Sine 2x is there. The 2 is way at the beginning with the other 2. That's why that's a 4. This takes a lot of practice. Number 22. S equals T. I'm going to make that red. Times the cosine of pi minus t, pi minus 4t. We're looking for the derivative of s with respect to t. This red and green is called a product. The derivative of a product is the first times the derivative of the second. The derivative of the cosine of something is negative sine of the same thing times the derivative of this thing. In this case, it's times negative 4. The derivative of pi minus 4t is 0 minus 4. Pi is a constant. And I need more space. Because the derivative of a product is the first, which is red, times the derivative of the second plus the second, that's cosine 4 minus pi minus 4t, times the derivative of the first. The derivative of 1t is 1. So there's the answer. I'll just clean it up a little. All this at the before the plus sign. There's a negative times a negative. That makes a positive. This 4 way down here, we'll put that in the beginning. This t will bring down this stuff. Sine of pi minus 4t just gets copied. And after the plus sign, we have cosine pi minus 4t. And that's as simple as you can get. Two negatives here, multiplication. That's why this first term is positive. Okay, number 56 has many parts to it. I think we'll just do part D. Oh, maybe we'll do part F. Part F. There's some function there that I'm going to call H. So in exercise 56, we're just looking at part F, where it says the square root of f of x. I'm going to give that a name. Let's call it h of x equals the square root of f of x. It says something about add x equals 2. So what's given is the square root of something, which means we can write that something to the 1/2 exponent. The derivative of this, which I called h, the derivative would be h prime. So here's how the chain rule works, or the power rule. We take the number that's in front here times this exponent, 1/2 times 1. Whatever's here gets copied. The 1/2 exponent becomes a negative 1/2, and we multiply by the derivative of what's in these parentheses. F of x is in there. The derivative would be f prime of x. So what it's asking us to do is evaluate the derivative at the given value of x. So now that I have this, we're going to say the derivative at the given value of x means every place there's an x, we're going to put 2. It's the given value of x. So I'm just really copying what I got using the power rule. But now I made this x and this x and this x 2. And then you look at a table of values that's given in the textbook. You'll see that f of 2 is 8. So the 1/2 in front gets copied, the exponent gets copied. So we're getting the value f of 2 equals 8 from the directions. F prime of 2 is in the directions, is 1/3. Now we just have to simplify that. 8 with a negative exponent means 1/8 with the same exponent but losing the negative. So we have 1 times 1 times 1 in the numerator. 2 times 3, which is 6. 8 to the 1/2 means the square root of 8. So that could be the answer. We would accept that answer. But if you're clever, you might think of multiplying this denominator by root 2, which you could do as long as you multiply the numerator by root 2. Top and bottom by the same thing. The numerator is now radical 2. And the square root of 8 times the square root of 2 is the square root of 16. That's why I used 2, because I knew 16 is a perfect square. The square root of 16 is 4 times 6. So I'm calling that the final answer to part F, exercise 56. I'll say again, though, if you called this the final answer, we would accept that.